Good morning to all. Myself, Dr. Arun Egame from Aerospace Engineering Department. Today, I am going to take one topic from Fundamentals of Aerospace Engineering subject. The topic name is Turboprop engines. So, in that topic, I am going to take the 5 stages of DT. First one is empathize. So, in that empathize part, the role of turboprop in regional aviations. So, before the invention of turboprop engines, the previously the engineers are used for this piston engines. So, in that piston engines, there are a lot of drawbacks we will found. So, like improper fuel supply, ignition problem, camshaft and inlet and exhaust valve not open properly. These are all the cases we have found in that piston engines. So to overcome this problem, the turboprop engines it can be developed. So by using these cases, the in that turboprop engine, first the Pratt and Whitley PT6 engines are developed. So in that cases, the it can be fly over the 500 miles. So in that turboprop engine, the propeller it can be used to suck the air, and in that air it can be supplied to the engines. Next one is the layout, and in that different stages, this is the layout of turboprop engine. So in the turboprop engine, many components are used. First one is core gas turbine. So inside the core, there are several parts are there. First one is a compressor, combustion chamber, and turbine. So that compressor, it can be, uh, it will useful to compress the air, and that air it can be came from the suction part, like the propeller, it can be suck the air and allow inside the cylinder, and directly it can be passes through the compressor. Next one is the combustion chamber. So in that combustion chamber, compressor air it can be travel from compressor to combustion chamber. So here the fuel it can be supplied to the combustion chamber area. So during these cases, the fuel it can be mixes with hot gases. The burning will happen. Next one is turbine stages. So in that turbine, it can be used to look like a exhauster. So in that exhauster, we are using for this kitchen area. So inside the hot gas or smoke, it can be sucked inside the kitchen, and it can be throw uh, with the help of exhauster. So same cases, the turbine can be suck the hot gases in the combustion chamber, and it can be directly the flow through the nozzles. Next one is a power transmission. So in that cases, all the power transmission it can be done with the help of the gearbox only. Next one is the propeller thrust. That already I told you. So in that propeller it can be used to create the thrust. Next one is a turboprop anatomy. So it can be classified into 4 types. First one is a gas generator, free turbine, reduction gearbox, and propeller assembly. These are all the engine anatomy for the turboprop. Next one is a ideate part. In efficiency discussion, the why turboprop we are going to use for the good efficiency. So in that performance characteristics, it gives a very high propulsive efficiency compared to the other type of engines like turbofan, turboshaft engines. So in that cases, the high bypass ratio also found this type of engines, and it gives the more thrust with the help of the propeller. So the major drawbacks is if the Mach number is around 1.3 only, and if the maximum cruise speed is below zero point 0.8 Mach only. In that efficiency cases, the turboprop wins, and it is a comparative study of turboprop and turbo fan. So in that turboprop, it gives the fuel burns 50 to 30 percentage lower than the jet engines, while compared to the turbofan engines, it gives the more efficiency at high speed. So the better the fuel efficiency will produce for the turboprop engines only. Next one is in the prototype stages, the matching turboprop to the aircraft mission. So here the turboprop engines we have used for this regional passenger transport. Around the 68 to the 70 passengers are traveled in the flight ATR 72. Next one is the Bombardier Q 400. Here the 70 to 90 passengers are travel in this plane. And next one is the cargo flights. And now the cargo and surveillance flights, it can be used for this to monitor the other country and to monitor the criminal activities in that India. This is a one case study. So in that case study, the Pront and Whistler, the PT6 engine family. So here the generally the this type of flight it can be developed in the year of 1960. So the totally the 500 plus aircraft models are produced by using the Pront and Whistler PT6 engines. So in that engines it produced maximum 2.5 kilo horsepower it can be produced. Next one is the emerging trends and applications. So nowadays the hybrid electric engines are developed with the help of the hybrid one is for liquid fuel, another one is for solid fuel. So the both it will be mixes with it will create the uh, thrust during these cases and multi-fuel capacity. So in that multi-fuel capacity means generally the in previous cases generally we are using the white petrol for a safe fuel. Nowadays they are using the many type of fuel like LPG, hydrogen, diesel, biofuel. These are all the fuels we are using. So the continuously we will give the more concentration to produce the emerging trends and application of upcoming carrier routes. So thank you. So we will catch you on next topic on next video.